Hi, I'm George.
And I'm Kristi.
And we're going to talk about the environment that we've been working on and some of the requirements that we have on OpenStack for it. We'll also talk about why they might be interesting to you. And finally, Kristi will talk about how we've been solving these issues. So we're from the Massachusetts Open Cloud, which is a collaboration between 5 research universities in the Boston area. We're working together to set up a shared cloud environment for research. Now the thing is, each university's IT department doesn't really trust each other enough to have a single shared OpenStack cloud. And they don't trust us enough either, because that gives us too much control over their hardware. So they might want to give us less control by doing something like setting up their own OpenStack cloud and using federation between them to give other people access to resources. All of this infrastructure is being set up in a shared data center funded by the universities. So there is not too much overhead from network latency or anything like that. In the future, we hope to also have infrastructure provided by our industry partners, which people would also be able to use for research. And in the same way, these industry partners won't want to relinquish all control of their hardware to us. So they'll probably also stand up their own OpenStack clouds and use federation to give access to the resources. Now, this sort of environment, where there are many different people providing resources, all through federation, and users can pick between them as they see fit, is something we call an open cloud exchange. And one requirement for this is that users should be able to combine resources from different providers. So for instance, I could have my VMs running at Northeastern, but my storage all at Harvard. And that's a feature we call resource federation, and that's something that we have had to create. Now, here are some things you might want to do as a user with resource federation. So different users will have different requirements of their storage. Maybe someone needs HIPAA compliance. Someone else needs particular storage attributes. Maybe they have more reads than writes. And it'll be different for everyone. So each person might pick a different storage provider that suits their needs best. And this is better than having a central scheduler pick what's price optimal, because it doesn't know what your requirements are. Another use case is if you have an existing setup with a lot of compute and a lot of storage, a new compute provider appears that you want to use. Maybe your company set up a new OpenStack cloud with new compute, or maybe a new provider in an OCX appeared. You can move all your compute to there without having to do anything to your storage, because maybe the storage would take a very long time to move. Using resource federation, you can move just the compute. And finally, on a more tentative level, there are cryptographic protocols that let you outsource computation securely, but usually they have some requirements on who you're outsourcing it to. In particular, there's one that lets you outsource it to untrusted parties as long as you know they're not colluding against you. And an OCX with competing commercial companies might be a case where that security requirement is fulfilled. Now, even if you don't buy into an OCX, there are a few cases where I think resource federation could be very useful. For instance, if you have a production cloud and there's a new service you want to add to it to give users access to it, but it isn't really stable enough yet, or maybe it isn't secure enough yet to put it in the main OpenStack cloud. If it's compromised, when an OpenStack service is compromised, if they get access to tokens, they could get to the rest of the cloud too, which would be bad. But instead, you can put it in its own OpenStack environment and use identity federation to give people access to it, and then use resource federation to let them combine it with other things. In this way, any attack against it is contained and any failure is contained. In a similar way, you can run multiple versions of the same service side by side. Normally, these would conflict in Keystone's service catalog, and users would only see one. But if you use federation and put it in a separate OpenStack cloud, then they can both be there at the same time. And finally, even if you have a normal setup and you don't have any unusual services and it's one version of everything, by putting each service in its own authentication domain, each in a separate cloud, you get defense in depth, because now compromising one doesn't give access to tokens that let you compromise every other service at the same time. So now I'm going to talk about what we want the user to see when they're using a system like this. The user should feel like they have a single project that spans all of the service providers available to them. If they list their resources, they should see all the resources no matter where they are. They should be able to do normal OpenStack operations like booting from an image, even if it's in a different service provider than where they're starting the instance. Or similarly, if they have an instance in one spot and a volume in another, they should be able to attach them, just like normal. And now Kristi is going to talk about the changes we've been making and what we've been doing to enable those use cases.
Okay, thank you. So our current implementation takes the form of a proxy, which will replace the image and volume endpoint and forward the appropriate API requests to the appropriate service provider containing the resource, or to multiple service providers if the user wants to list resource across service providers. To allow authentication between multiple OpenStacks, we are building upon a feature called Keystone to Keystone Federation. This allows users, this allows federation of identity across OpenStack. So a user can exchange a token in one OpenStack cloud for a token in another OpenStack cloud, giving him access to the services provided by that cloud. Now, how do you know where to forward the request to? The first implementation was to search by querying multiple service providers until one of them says, hey, I have the resource. This does not scale too well, as you have to authenticate with multiple service providers. However, this overhead can be reduced by caching the tokens or the location of resources on subsequent requests. But ideally, the proxy would already know where the resources are. Our second implementation, and we currently support both implementations, is to listen to the notifications on the service providers for messages of volumes or images or snapshots created on it. Therefore, the proxy would learn where the resources are located before the user requests access to them. The locations would be stored in a database local to the proxy, so query time would be very fast. This, however, requires a greater degree of trust, as there would be an agent listening to the message bus, which would forward these notifications to the proxy. We have currently tried and tested, and then it works with two volume backends. The first one is iSCSI, and it just works. Credentials are passed through the Cinder API, so no more access is given than is required by the proxy. With Ceph, it works. However, one authentication key grants access to the entire pool of volumes. And the authentication key must be present in all compute nodes which require access to that backend. We are currently working with the Ceph team to address these issues. So here's the characteristics of this solution. So first, it works without any API changes and with no code changes in any of the OpenStack services. It satisfies our goal of increased security, so service providers don't have to trust each other as much. And it works with good performance and preserves our current API, our current user experience. User can use OpenStack client or Horizon or whatever dashboard they are using. So there is more work that needs to be done to provide a universal resource federation solution. Currently, we have only been working on the storage and on the block storage and image storage scenario. More work will be done for federation of networks, and we're currently working on becoming an official OpenStack project. Thank you.
Thank you.